Hello everybody. Once again I am here with you for the another session which is to be last part of this mechanics, and basically we are discussing for the last point, which is to be related with the motion of a body near the surface of the earth is to be there, in which we have seen little bit part as far as when the basically the body is moved upward in direction. Now let's consider a body having the mass m is to be there, as it is to be mentioned here, that is to be mb, the mass situated at the rest on the earth's surface, considering the height will be the h, and at that stage the potential energy is zero exactly when it is at the rest on the surface of the earth. If the body is moved at a distance x in the normally upward direction, in that case whatever be the work done by the gravitational force is nothing but to be minus mg is to be on the body is to be there, and basically it is to be, now the direction is to be in the upward direction, and that's why here it is to be the given. I will manage this one. Yeah, the work done in that case when the body is moved in the upward direction, and in that case it is the whatever be the work done total from the height h to x is to be there. It is having the basically integration, if you look at carefully, it is giving you w is equal to h to x minus mg dx, and that is how the, if you resolve this one, that is to be minus g, it is giving me minus of mg, and this one is to be there, minus of mg dx is equal to minus mg, that is x minus h is to be there, and if we take it is to be as a minus multiplied with this gate, excuse me, that is giving me mg into h minus x is to be there, and this is how the relation is to be there. But the another important factor here, it is to be the direction, where the direction of the force is opposite to the x is to be there. That means if I am putting this in the upward direction, the body, no doubt the force will be in the opposite downward direction. If I am putting this to be in the upward direction, the force will be in the downward direction, that is opposite to the position of the x, and the position of the x is to be, this is what the h is to be there, and I am putting it from the surface to certain distance x is to be there. So it is the whatever the force will be there, it is in the opposite to the direction of the x is to be there, and this work done will increase the kinetic energy, and basically how much amount of kinetic energy is going to be increased, that is w is equal to, given with kinetic energy, that is nothing but to be half mv square is to be there. So this is what the w is equal to half mv square, and again if we look forward for this case, again this half mv square is equal to, I can write mg into h minus x, whatever the work done I have calculated previously. So it gives me the new relationship, and that is nothing but to be mgh, again mgh minus mgx is to be there, half mv square is equal to, and if we will take mgh as it is in the right side, this mgx will go to the left side, and it will give me the new relation mgh is equal to, this mgh is equal to half mv square minus of mgx जे आहे ते इकडे गेलं तर प्लस होऊन जाईल, that is half mv square plus mgx is to be there. This is what the relation to, which gives you the new relationship. As far as these relationships are going to be concerned, when body is situated at a height x, potential energy is nothing but to be mgx. If I am putting this at distance x, the whatever be the potential energy is going to be at height x, whatever be the potential energy is nothing but to be mgx. at the rest it is zero. potential energy जर समजा बॉडी ती रेस्टवर असेल तर झिरो असेल, पण ॲट अ सर्टन डिस्टन्स एक्स एवढ्या हाईटवर मी जर त्या बॉडीला नेलं तर त्याची जी पोटेन्शियल एनर्जी आहे ती किती इन्क्रीज होईल, दॅट इज एम जी एक्स विल बी दॅट. हॅन्स द इनिशियल whatever be the initial body has only potential energy, that is to be as an u is equal to mgh, and no kinetic energy is to be there, that is k is equal to 0, because kinetic energy is going to be 0 at that stage. and here the initial total energy K plus U is equal to 0. Let me correct it, that at the rest whatever be the potential energy is to be as in having to be mgh is to be there, not mgx. It is to be as in having the kinetic energy is going to be 0 at this surface area, and initially at the initial stage, and the total energy, no doubt kinetic energy plus potential energy is to be there, and that is somehow given with the relation K plus U. U is the potential energy, K is the kinetic energy. As far as K is going to be 0 at the initial stage, we are calculating the total energy. It will become 0 plus mgh is equal to mgs. That is what the initial total energy is to be there. Again, moving forward, if we गो फॉर ॲट हाईट एक्स, म्हणजे जर समजा मी बॉडीला समजा ॲट अ एक्स डिस्टन्सवर नेलं आहे, त्यावेळेस जर मला टोटल एनर्जी काढायची आहे, फायनल स्टेज म्हटलं तरी हरकत नाही, ॲट एनी हाईट दॅट इज एक्स, total energy is nothing but to be again kinetic energy plus the potential energy is to be there. And again I can write this K plus U, and it will give me nothing but to be half mv square plus mgx. Why mgx is to be there? Because now body is at a certain distance x and having the potential energy, there is mgx is to be there, then that's why it is going to be becoming to be half mv square plus mgx is equal to mgh is to be there. So this is what the new relationships we found, and exactly the at the earth surface x is become to be 0, then in that case the total energy at this stage, the surface area, K plus U is equal to half mv square plus 0 is equal to mgh in this case. So in that case we can write that mgh is equal to half mv square. So what it gives me, that is the kinetic energy is equal to mgh. And what is mgh? Mgh is nothing but to be potential energy at surface area, and hence the sum of the potential and the kinetic energy of freely falling bodies remains constant is to be there. That means to be kinetic energy is equal to the potential energy is to be there, and this what indicating that the sum of the potential and the kinetic energies of the freely falling bodies remains constant throughout the motion is to be there, and that is what the case where it is to be, we can say that whatever be the your calculation part is to be there as far as the motion of the body near the surface of the earth is to be there, it is to be as an kinetic energy, and the potential energy of the freely falling bodies remains to be a constant in the throughout the motion is to be there. Another part about the non-conservative forces, as far as the conservative forces, we know that the work done is to be dependent, work done by the force is going to be moving between the 2 points, and it is not in the conservative forces, that is to be not dependent on the paths are to be there. But as far as the non-conservative forces, it is very simple to be the work done by the force on a particle, particularly moves from between the 2 points, depends on the path, and that is what exactly the conservative forces are to be there, sorry, non-conservative forces are to be there, depends on the path taken between these 2 points are to be there, and it is called to be as non-conservative forces. And in simple way, the friction and the viscous forces are to be there, and for conservative forces the sum of the kinetic and the potential energy is going to be the constant K plus U, no doubt it is going to be a constant one is to be there, that is K plus U is equal to total energy E is equal to 0. That means delta K plus delta U is equal to 0 in that case. As far as this part is going to be concerned, but the work done by the conservative force is equal to the negative of the increase in the potential energy, that is जर समजा delta K plus delta U is equal to 0 असेल तर delta K is equal to minus delta U असं आपण जसं म्हणतो, म्हणजेच that is to be as an conservative force, the work done by the conservative force is equal to the negative increase, that is to be WC is nothing but to be conservative forces are given by the work done by the conservative forces to be there, and that is somehow it is written as a WC is equal to minus of delta U is to be there. So if you look at this case where it is to be said to be that WC is equal to minus of delta U is to be there, that the work done by the conservative force is equal to the negative of the increase in the potential energy part is to be there, and that is what it is given by this relationship. And the negative potential energy, that is to be WC is equal to minus delta U, is to be there. Now let's consider, in addition to the conservative force and non-conservative force, says a non-conservative force due to the on the particle, what happens exactly if Wf is the work done by the frictional forces, and Wc is nothing but to be the conservative force is to be there. And then the work done, basically Wc plus Wf plus Wc on the particle should be equal to the change in the kinetic energy k of the particle. And that's why Wf plus Wc, it is not clearly shown here due to the print missed limitations. Wf plus Wc is equal to delta k is to be there, that is to be changes in the kinetic energies are to be there. As far as this relationship move, we know that Wc is nothing but to be minus of delta U is to be there. What is exactly it is to be there? That the conservative work done, the work done by the conservative force is nothing but to be negative amount of the potential energies part is to be there. And that's why if we replace this relationship to be as an Wc is equal to minus delta U. Now if we are replacing in this relationship, then we will get something addition relationship, that is to be जर समजा ह्या Wf प्लस Wc इज इक्वल टू डेल्टा के, ह्याच्यामध्ये जर समजा Wc ॲज ए मायनस ऑफ डेल्टा यू जर मी ह्याच्यामध्ये ॲड केलं, तर हा मायनस ऑफ डेल्टा यू ह्या इथं जर पुटअप केला या ठिकाणी, तर आय कॅन राईट Wf इज इक्वल टू डेल्टा के प्लस डेल्टा यू इज टू बी. हा मायनस इथं असल्यामुळे हा इकडं जर गेला तर काय होईल, प्लस होईल. So in that case I can write basically delta k plus delta u is equal to Wf. But what it indicating, this equation shows that if the frictional forces acts on the particle, then the total energy is uh, not going to be the constant, but the particularly the frictional forces, that is to be the change by the amount of the work done by the frictional forces are to be there. And delta E is equal to E minus E0 is equal to Wf is equal to there, and that is what the change in this particular case is to be. But if Wf is always negative, hence in above equation the final energy E less than the initial energy is to be there, and the E where the initial energy is to be as an E0, the lost energy is appear in the form of heat, that is the heat energy developed in the exactly equal to the energy dissipated, and this heat energy Q so produced is equal to the work done by the particle. If Q be is the heat energy developed, then Wf is equal to minus Q is to be there. So heat is going to be dissipated in this form of sorry, the energy is dissipated in the form of energy heat is to be there, and this is given with the Q part. As far as the Wf is to be always as a negative, uh, in that case Wf is equal to minus Q, and delta E plus Q is equal to 0. Therefore there is no change sum of the mechanical and the heat energy of the system so far conservative, we can say, or the frictional forces are acting on the system. So as far as this delta E plus Q is going to 0, that is there is no change in the sum of the mechanical and the heat energy. म्हणजे दोन्ही जर ॲडिशन it means the 0, that means to be the system so far is conservative, we can say, or the frictional forces are acting on the system. Then the total energy is said to be conserved. या केसमध्ये total energy we can say is to be conserved. Similarly, if other conservative forces are acting, then the mechanical energy lost in the conserved into the other form of energy, hence in general total energy is conserved. So delta E plus Q plus change in the other form of the energy is going to be 0. The total energy is always conserved. Kinetic energy and the potential energies are conserved only when this particularly conservative forces acts are to be there. For the non-conservative forces it is not like to be there. So again to be as an the situation is becoming to pandemic. And so thanks for joining this session, and be at home and be safe. Thank you.